looking at like a. Oh, okay.
All right.
I don't know if you're getting my video stream. It's
Yep.
been a while since I used Zoom, so okay. Hi, I don't see myself, so I assume it's at a decent angle and I'm not just seeing like my mouth and my neck or something. um, Nice to see. I recognize some of you from coronavirus times, I think. Been quite some, that was quite some time ago, but it feels quite it simultaneously feels like just a couple months before, but also really long ago. Um, so I'm right now in Scotland. I think the last I spoke to some of you, I was in India, but I've been in Scotland for a couple of years now. I'm doing my PhD in artificial intelligence and LLMs and all that jazz. Um, so that's me, and I think we also want to see what we're expecting from this call.
Yep.
I'm just excited to see what new papers are coming up, and if if there's terms that I recognize from my ongoing research, or if it's new things which I might feed in and cross pollinate and so on.
Awesome. Awesome. All right, Jack,
Thanks.
who you are
Jack.
and what you do and what you expect from this session.
I'm Jack. I'm a software engineer who dabbles in AI, but I'm not I'm not like a PhD researcher or anything like that. I've sort of have a little bit less experience than some people here. Artur, Anton, and a couple other people of us are working currently on a language challenge. I have a lot of interest in language and AI's applications to language. And yeah, I have a lot of thoughts there, but I won't take too much time. Malavika, I think it's kind of interesting. It sounds like you have a little bit of a Scottish accent. I don't know if you've been there for a couple of years. Maybe that's like starting to develop.
Oh my
But,
God, is it?
I
I could.
Yeah, no, I mean, I feel like I caught a couple of words that just sounded sort of Scottish to me.
I
It's
think
one of my
me too.
all-time favorite accents.
Yeah, I do love a good Scottish accent.
Yeah.
So can I sorry about the Scottish accent, if I can say, like there was this Geoffrey Boycott was one of the, I think he's Scot, right? Like he was one of the most greatest legendary cricketers, and cricket is big in India. So he had like when he used to come for cricket commentary, he'd say like run and put instead of run out. And in our school, like we used to mimic him, he used to practice like talking like Geoffrey Boycott. Anyway, that's the thing. Sorry.
Yeah, no problem. Yeah, I know the Scots say for house they say hoose. Yeah, and I'm just here to, I've gotten kind of involved with Arthur's various projects, found it really fascinating that you guys have everything related to PolyAgent, and thought this sounded really cool. I'm also just trying to get better, like learn more about AI. I enjoy conversations like this too. So I just jumped at this opportunity to do this. So
Awesome.
yeah,
Awesome. All right. And Sunny?
Hi everyone, how's it going? Can you hear me?
Yep.
Awesome. Hey, I'm Sunny Bhatia, working on my master's computer science, and my focus right now is on cognitive agents. So PolyAgent is a great fit. Really enjoying watching all the papers and learning, because that's what I've been doing for the last year or so, but it's not been as structured. So just having the community and structure has been very helpful. Last few weeks I've been like deep into my thesis, so I haven't been participating a whole lot, but I am getting ready to publish what I've been working on, and I'm putting everything on a website, so I'll share that with the community very soon, and I think you'll find it interesting. Biggest thing I'm doing right now is using LLMs to actually reason and make decisions. So I have a I can go more in detail on my research, but I don't know if that's what we're doing right now. So I just wanted to keep it simple for now. So
Yeah, just quick interest.
yep. So that's who I am. Good to be here. Looking forward to know everyone here.
Awesome. Awesome. Thanks. Raphael?
Yes. Hi, everybody. Can you hear me?
Yep.
Hello. So quick introduction, and I'm sorry, I'll turn on my camera in a moment. I'm came back from walking my dog and it took a while to get in. But long story short, I am a software engineer. I work for a tech company that specializes in experience metrics. So you can think of it about, sentiment primarily, but there's a lot of other enrichments and metrics that we try to derive out of text, usually transcribed audio, to just understand how people feel about things, right? And we've been doing machine learning models since at least 2014. We used the first TensorFlow versions on bare metal, and we've come a long way since then. I work very closely with the machine learning specialists and the people who do the R&D function. I'm not a researcher. I'm not a PhD. I do have a master's, and I generally focus on data engineering challenges. Summarization in particular is extremely relevant to me. I was involved kind of tangentially since the Corona days. I had some personal issues back then that didn't really allow me to focus, and I'm also hoping to reconnect with the community and just pick up interesting, work to do together. And I'll stop there. Yeah, excited to see everyone.
Awesome. You work for Qualtrics, right?
I do, yes.
Awesome. Yeah, I mean, amazing company. So great to have you here, and yeah, super interesting background for sure. All right. So I think we're good on the list of current participants, and let's jump into the topic. Obviously, summarization, something that I think every single person that tries to do something with LLM definitely tries out summarization as the simplest use case. And it does sound very simple. And it's very simple to try it out on, day-to-day tasks. We've all seen people experimenting with like summarize the YouTube video, something that, every indie hacker, indie developer, researcher does in their free time as the experimental project. But in reality, it's actually very hard to deploy these techniques in commercial or practical various environments, simply because we don't have a go way to evaluate the quality of these summarizations. So this is where the topic comes in, and we've picked out two papers through the actual recommendation engine, or notebook that Wendy crafted last week, which was an awesome showcase of our internal tool that we're building towards the researcher agent. And the two papers are Identifying Factual Inconsistency in Summaries Towards Effective Utilization of Large Language Models, and the second paper, TrustScore, Reference-Free Evaluation of LLM Response Trustworthiness. And I'll kick off with the first paper. The first paper is quite interesting because it presents three different zero-shot evaluation frameworks: the SUM NLI, NLI, SENT NLI, and QGQA. The SUM approach scores the factual consistency of the entire summary in one pass. The SENT scores consistency by each summary sentence and then aggregates the score. And the QGQA explicitly verifies the entities through the question generation and answering. Super interesting because those are very practical, and I guess I'll shut up and give you guys some space. Maybe we'll start from people that read the paper and have some thoughts about it, or maybe some ideas or immediate reactions.
I could start off with a couple of thoughts. With the first paper that did the sorry, let me get the names in front of me. the identifying factual inconsistencies and summaries. It was interesting to me, especially, you know, as a guy who's kind of coming into AI, but isn't, you know, again, like necessarily as experienced as some of you, how intuitive some of this stuff was. Like the fact that, you know, this summary based version struggled more with longer summaries and you know, things like that. So I thought that was really interesting. It was also quite interesting that, like, just that with these three approaches that, you know, obviously this is very sophisticated, but, you know, the approaches themselves, which was like either have the LLM judge the whole thing, have the LLM judge, you know, kind of like sentence by sentence, or I think it was like groups. I forget if it was each sentence or if it was groups of sentences, or break it into just literally fact check the individual entities. Again, it's like very similar to what, you know, if you approach this person, you know, this fact checking as a person, how one might approach it. The TrustScore paper, I found.
Hold on, we're doing paper.
Oh, sorry.
Paper.
Oh, sorry. Okay, yeah. So anyway, in conclusion, there's a lot to talk about, but I thought the intuitiveness was very interesting.
All right. I think Wendy, you unmuted yourself right before.
Yeah, so I guess for me, it's actually one of my previous projects was exactly on this task around summarization. And what we found with this sort of setup is that it's actually so kind of like when I was working before, we're not really allowed to use ChatGPT. So, and kind of like because we can't send data outside of our own premises. So what we found was that we tried to use the same model for this sort of like fact checking setup. And actually it's also true that the model can very confidently answer that your summary is correct when it's not. So I think kind of whether so there's probably some tricks that I need to dig more into this paper to understand, because what I also find is that this paper is not the easiest to understand, especially like a lot of they left out a lot of details around how the different tasks work, and they kind of like point to all these references that you're supposed to also follow through, which is a kind of like doesn't really help when you're trying to read a paper. Yeah, and that kind of I think I also want to find out more about what they're doing in terms of like distillation, because I think that will be very useful for kind of like people who want to do these things on a larger scale but not kind of spend a fortune on OpenAI. I think like in my some of my current work is also involved in like this like deploying some of distilled models for our own use case. And what we find is that it kind of distillation is really useful because it kind of lets you more or less get almost the same performance at like a fraction of the cost. Yeah.
Super interesting. I was actually also very interested in the distillation topic, simply because if we're talking about summarization at scale, and you know, trying to do one of these frameworks for the scoring, the cost will be astronomical. And especially like for some of these simpler tasks, like the entity generation and answering, this for sure can be done with a much smaller model, or the analysis of the consistency per sentence. Obviously, the larger sum and LI is much harder with the smaller models, but I think the smaller the task is in terms of decomposition of the subtasks, the higher probability of a smaller model having a better performance. And when it comes to the distillation, they tried Vicuna model. And I actually haven't played around with this model, and I was surprised to see that it performs so much better than other models, and you know, close enough to GPT performance. So super cool.
Yeah, I think like what's the most fascinating about this paper is just again like the improvement with just kind of like applying chain of thoughts, kind of prompts, creating this three scores, you know, merging them together, and boom, you start to get like some really good results. And I'm always excited by anything that is chain of thought derivative. I was super excited by that original paper like a year ago, and I had the chance to actually be at the presentation of the authors of Chain of Thought. And since then, like it's fascinating to see how those like initial ideas get manifested in all of this kind of not derivative work, but applied to all kinds of problems.
You know, Arthur, you brought up something I thought I had a question about, which is that they call out that the QGQA uses more resources effectively because you need to do a pass to do the entity recognition, then a pass to like, you know, verify those entities. But you said something which I was thinking, which is that the entity recognition part feels like it could be done with like a small targeted model. Like that doesn't feel like it needs anything. It wouldn't need, like, you don't need like ChatGPT 4 or whatever. Like it's you know, that, so in terms of resource management, I was curious if I had actually missed something there. Because they were talking about the fact that I had to do 2 passes to do that. Whereas I could imagine a world where you basically had 2 different models, one for entity recognition that was much smaller, and then one for the, you know, the actual fact checking.
Yeah, and there are a bunch of models that are fine-tuned for NER task, the named entity recognition. And basically, you can fine-tune your own model based on the NER data sets and just fine-tune specifically for this QC stage. So, I mean, for their research purposes, obviously this wasn't the topic of research, but this what I would do in a commercial environment.
Yeah, that's actually a pretty good observation. That's in fact how things work at least in the corner of the world that I know. There's a fair amount of pre-processing before going to summarization. So named entity recognition, a lot of like lexical simplifications, especially for non-English languages. For many non-English languages, there's a fair amount of kind of text normalization. But yeah, I'm actually, it's an interesting development because summarization, and particularly factual checking in summarization, has been, I mean, remains an open problem, at least in the commercial area. It really, the applicability of solutions like this really depends on, what's the cost of an error, right? And in many places, it's acceptable to not have 100% factual accuracy. But I recently worked with a biotech company where they're trying to, essentially, I mean, do pretty strict kind of inference based on a large body of research papers, and at that point, summarization becomes a daunting task. Like I don't know, as far as I know, in that industry and with that level of factual accuracy requirements, this is still an open problem. I mean, we know that already, but what I'm trying to contrast is that in many scenarios, it actually works quite well, right? For example, if you're going to do sentiment analysis at scale, and you want to get, you want to summarize long telephone calls between agents and clients, and then do dimensional analysis on what you extracted. That is actually actively used. I mean, there's a lot of room for improvement, but because the tolerance for inaccuracy at the micro scale is pretty permissive, there's definitely a lot of activity and a lot of development on that side. Whereas in these other, much more strict areas like, legal and medical, it's almost, it feels like an entirely different problem, although it's not.
Yeah, definitely. I mean, I think it also goes back into the context of the conversations. If we're talking about the summarization of a pretty homogeneous type of data sets, like the um, call center support, right? Like the
Yeah.
summarization becomes such an easy task because there's a definitive range of situations that we're talking about, especially if you fine tune the model on that data set. And if we're talking about even summarization of the scientific papers, the papers that we're talking about, there's definitely a much higher variability because of different papers, different approaches, different methodologies, and all of these things. And even, the way that people write the papers. So to me, it's also about the underground like foundation, like where the data is coming from.
Yeah. Yeah, that's a great observation. In fact, it was funny because when ChatGPT, kind of broke into the public consciousness and, the big, when BERT was released, it was a big transformation because I started working on the summarization problem alongside a bunch of other NLP issues. When the only feasible approach was really to essentially have like a template, as you said, for call centers, there's a greeting, there's a presentation of the issue by the client, there's a presentation of potential resolutions, blah, 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 follow. So the initial versions of this were actually just a little template that would have fields like, all right, insert sentiment here, insert reason, insert, topic classifications in here and there. And that was a commercial product. So then transformers happen, and then the rest is history. I mean, that completely, yeah. I mean, you guys are well aware of what happened, but it is interesting that the consistency of the problem is really what dictates the applicability of the solution, right? Because call center, sure, there's certain types of banking transactions like loan refinancing, for example. It's very complex. You can get transferred 5 times and talk to 7 different people, but in the end there are very strict things that have to happen, right? They have to read you your mini Miranda rights, and you have to detect that to figure out, for example, what is being read as just like legal verbatim that they're obligated by regulation to do. And it's very important to segment that out, because if you factor that out as free-form text, it completely changes the so anyway, there's a lot of interesting issues there. But I think it's very accurate to point out that this particular context is critical for the viability of solutions. I mean, I have to give you a contrast, right now there are applications to essentially allow call center agents to search the knowledge base, right, as they're talking to you, so that they don't have to type. That's easy. We can actually do this, right? I mean, you just turn this into keywords and you fire them at an API, but the challenge is that doing the transcription and doing the actual LLM evaluation in real time, that's not easy, right? I mean, the cost is prohibitive. Yeah, exactly. So I mean, cool solutions, but it's just there's no way to make it work. So that's another point. Why I was very interested in talking to you all in this group is to figure out model quantization and other kind of efficiency developments in these models, because there's no doubt that they can do these things. It's just cost, right? So.
Yeah, super interesting. And thank you, Raphael, for joining in. You bring, I think, a perspective that many of us miss by being, so deep into research. But just hearing you describing all these use cases is super helpful. So.
Oh, glad to hear you. Excited to be here.
All right, Anton.
Yeah, so I wanted just to chime in on the topic of cost and why, like, Artur bring it up to kind of explain to Jack and the rest of the folks who are like not part of the CoronaY action 2020. We got extensive experience of running named entity recognition pipelines they were expensive, and we got quite a bit of experience of tightening up the costs there, which is simply, instead of running latest and greatest spacing models on like GPU, we kind of like, wait a second, those specific models from Spacey could be run on CPU. And then if you do experiments, Intel versus AMD CPUs are actually like more cost effective in the end than Intel CPUs. In the end, we had the team who were running AWS bare metal AMD like multi AMD like core instances that the instances themselves were like very expensive, but you run them for slower, like for less amount of time. So for example, like the pipeline to TrustScore 19 data set at some point costed us like $150 per run, was down to 73. I remember because I was allocating budgets for that. So that just kind of like thing. It's that's what I love about our like community of all of the different perspectives, people who have this experiences of simply like, hey, if you ever focus on one specific narrow thing, there are like this factors that should affect decision making. Do you run LLMs for everything, etc.? I also want to point out like the message that Wendy left in the chat, that there's, I think, a big, also like I agree with the sentiment that like this year or like last year, like all of the users who were brought into the space of LLMs by ChatGPT revolution, for them before there is nothing, and now suddenly embeddings, all of that, it's all LLM based, which is again factually wrong. And just recently, I was at the LangChain party in San Francisco, and I was talking with the folks that were running, like they have startup that are building AI agents for like sales. So anyways, kind of like this very startup-y, heart of Silicon Valley discussions. And when the topic was brought up about embeddings and how we do stuff, the guys who were building like literally agents raised a lot of capital for that, kind of like, hey, if I'm going to do it right now, I'll just do classical recommender system based on classical embeddings. That's it, because it's so much more cost effective. So we definitely need to have this in mind always, that LLM and just using embeddings based on LLMs is great, because again, for a lot of toy examples, they work so much better out of the box. But the moment when you're scaling it out, you're back into the same that we had a couple of years ago. You need to experiment with, classical smaller embeddings, maybe build your own embedder that is tightly coupled with your data, your use case, but it's super efficient and cheap to run. Yeah, sorry for the long.
No, super relevant. I was actually, when Wendy published that Colab notebook with the recommender for papers, I was impressed. I was impressed how good this Stolbert MS Marco embedding was. Like, I was not expecting such a great performance, and it's super, affordable. Like if we would implement it at scale. So yeah, once again, thanks Wendy for bringing this up. I assume you've, had the bunch of experience and trial and error in commercial environment to find it. But yeah, it's a great thing.
So I mean, kind of actually the experiments are done before I joined the company. So but kind of I'm more like just doing deployments for that at the moment. But I know that from discussions with my colleagues that like kind of this is like the best that they've tried. So I thought, well, it's sort of exactly what kind of the use case that we're looking for, and for kind of like a first iteration of out of the box thing, then that's kind of a easy way to start. Yeah, I think probably like if we want to improve it, there are like other models that we can investigate, but it's kind of nicer just to have something working and then you can iterate. Yeah.
Awesome, thank you. All right, so before we jump into the second paper, anyone else has any thoughts on summarization in the first paper? Go ahead.
I had a kind of a brief question. Obviously one of the points of this paper is that the summarization does not work as well, or better said, it degrades with length more than the QA, QGQA and sentence oriented. was wondering if anyone, if there was, how to say this, if it might be missing something there in terms of like the fact that it does an overall fact check of the whole thing as a whole versus piece by piece by piece actually could pick up issues that wouldn't be present when you're kind of breaking it down into either its entity components or by paragraphs. This is kind of an open-ended question, but yeah, I was just sort of thinking if like the way maybe if you read like a philosophy text, like if you read one paragraph versus another paragraph, or you read something like you read Taleb, for example, there's a lot of jumping around, but then kind of things work cohesively as a whole. So I do wonder if there's maybe big picture, if there still is some advantage to doing a summary based, even though it's a little bit less looking at the whole thing cohesively. So yeah, kind of an unformed question, but just something I was sort of thinking about regarding.
Very relevant to the discussion of the context of large language models, because essentially the reason why very long inputs work much worse for the summarization is because the context is lost. And even with the big context models like the Claude, these crazy, million token inputs, the thing is that there is some research already. I think the paper is called Needle in a Haystack, where they evaluate things being missed in the middle. So basically the model captures the head of the context, semi-perfectly, the tail, but the middle is basically lost. And in the same way, when you chunk the text and try to evaluate that, you also lose the context, except, you control the context that you lose, versus when you're feeding the long context, you basically give up the control to the attention mechanism of the transformers.
So, quick question: needle in a haystack. Are those like heat maps, usually like green, and then red is position where? Okay, got it.
Yeah, that's the famous paper where they display the heat map of losing context.
Well, I'm actually like starting to see in a lot of presentations like exactly like those visuals. I think they're like very great at representing, like is it working or not, and just like everywhere I'm seeing them now.
Yeah, but also to piggyback, Jack, on the context length, this research paper haven't really evaluated this set of techniques for things like books. Like that's a whole different topic. Summarizing a book, like it's definitely a different problem than summarization of the call center call.
Oh yeah.
All right. I think we're good.
So kind of, I think
Wendy?
a random. So I have a slightly random comment, but I've seen one or two papers around kind of how not to lose the context in a really long, in kind of a really long input context. Or at least I think I have, but I can't seem to remember them. I can't seem to remember like the actual names of them. So I think there is kind of potentially things to look at if you have like really long inputs and want to not lose the middle bits.
Yeah, it's a whole different, topic of research. And usually the papers that I've seen that are coming out would be interesting to actually maybe do a topic on this, but they seem to be very, very technical. And that goes into the description of how attention mechanism works and stuff like that. And to be honest, even for me, like I get lost when I read those types of papers. So maybe that's a, worthy topic for one of the sessions for us to get our teeth into it and figure things out.
I think it'll be quite interesting, but similar to you, I'm not very good with the super technical ones. I kind of like when I read them, I sort of like, okay, now how do I actually deploy this super fancy technique?
Right. All right, I think we're good to switch to the second paper, which is the TrustScore paper, reference-free evaluation of LLM response trustworthiness. And basically, the core topic of the paper is using behavioral consistency as a measure of language model trustworthiness. And behavioral consistency, it's basically, the first time I read it, I was like, what is behavioral consistency? But basically, it just means that you expect the model to produce the same type of response and mimic the same behavior that it already done in the past. So they're just using that as a metric, and they're using an interesting prompting for it. They're generating distractors alongside the first initial response to evaluate if the model is consistent and will keep picking the same answer. So I found it very interesting, and it's an interesting paper because you can combine this technique with many other, pipelines to actually demonstrate the alignment of the responses with the intrinsic knowledge of the model. And yeah, would love to hear what you guys think.
Like I really love this specific paper because it not only like the idea is kind of on the surface if you think about it long enough, but then again, like how you actually implement this idea of, hey, if I ask LLM some fact, and then let me re-ask this fact as a multi-choice question, where one of the answers is from the first one, and then the rest are like those detractors, right? And then you can generate a bunch of tests like this. So it's kind of like clean way of how to take this idea of re-asking LLM with added noise in the context, but in a really good format. And then to point, like from this perspective of our discussion, hard to read papers and not, this is like very great paper because before appendices, you read it just like the flow of read is nice. You can understand what the authors are talking about. But then I don't know if all of you folks went to all of the very end with all of the details. There are like, again, pseudocode, how implement this, all of that is there as well in the paper, just not added in the context of, just the main body of it. So I think like it's one of the good examples that we could easily try it out for use cases that we will need a technique like this. And also in this specific paper, I like that they have this distinguishing. One of them is, like BC score, like trust BC, like behavioral, whatever, like the C means. Another one was kind of like, what if we bring external knowledge? So I know that within our community, we have people are very interested in knowledge graphs and all. And this will be very interesting. Kind of like, wait a second, this is exactly the way how we could bring knowledge graph into the mix, if we build like a score, something like this one. So I'm actually super excited by this paper, and I'm interested to hear more thoughts from the community on it.
And it actually connects to, because the trust BC is the behavioral alignment, and the trust FC, I think they called it factual consistency, is more, related to this QGQA thing from the summarization from the first paper, because there you actually have the explicit entity and relationships, and you just validate if that's consistent. Versus behavioral consistency, the other distractors may be completely, random, false statements.
I have a couple thoughts on this. I also thought this was really interesting, and Anton, I totally agree that it was very readable, like just like you said, well written and pretty easy to understand. And yeah, kind of going back, I started with the first paper, and then this was the second one I read, and I thought it was really interesting that this was attacking this from the angle, as they call it, intrinsic parametric knowledge, basically looking at what's baked into the model's weights, and kind of echoing my comment from the last paper, is that it takes an approach that's actually very intuitive. It's like ask it the same question over and over, give it the multiple choice, change the wrong answer, kind of give it like, almost the equivalent of like a police lineup, like give it a bunch of wrong answers, but make sure it gets the same right answer every time. To determine like, is this, and if I understood correctly, kind of answering the question of like, is this fact something that's built into the model itself? And yeah, I thought that this was a really interesting approach. So it's kind of it for me, but yeah, I thought it was fascinating.
Yeah, it's funny that you mentioned that, because I was precisely going to ask what people's interpretation was of the notion of parametric knowledge. So what do we understand that to be? And I mean, my read is, it is essentially the knowledge of the world that ends up embedded in the parameters of the model after you train it, right? I mean, is that what we understand? What other kind of knowledge is there for a model? Isn't it all parametric in that sense?
Oh, sorry, Artur, do you want to go?
I think you actually bring up a very good point in terms of when the hallucinations produce knowledge, because essentially we may assume that model may not have the knowledge and will hallucinate that knowledge, and that knowledge will be true. There is a probability distribution to that. You see what I mean?
That is a good point. Yeah.
Yeah,
some hallucinations are quite convincing.
Oh, sorry, go ahead.
No, sorry, I don't want to. I'm in a bit of a sound area, but I just wanted to quickly say, I wanted to give an example about this thought on a parametric knowledge. So, I work with this neuron simulations, and just with adenosine, I was saying like how, so we do these simulations in which you've got a receptor or a channel, and that channel has many parameters, and we distribute these channels on cell and run simulations and get an answer. Is, say, when you have too much block of adenosine receptor, like say with coffee, what is the overall change in activity, and therefore it's good or bad. So parametric knowledge is definitely important, because we have got this vast library of models and we have fine-tuned parameters, but that's not knowledge itself. That's not like asking the question. Using these parameters of these models, we come to a conclusion by running these simulations. I'm just trying to understand, like, the limits and the benefits of parameterizing knowledge. I don't know if that's an accurate comparison, though.
Yeah, thanks, Sid. And it's a whole different discussion on how does the GPT-like model actually learn, and what is that compression of the knowledge that it does, and what does the knowledge look like? Like, obviously, even researchers that are doing it have no clue, like in terms of the actual details of it. But the closest paradigm that I have at least picked out for myself is definitely compression. Compressing all the relationships, all the concepts, all the entities into the most, the smallest multi-dimensional space that it's possible for us to do that inference. And to build on the TrustScore concept, we're basically just making sure that answer exists in that concept space and is consistent. Because if it doesn't, we cannot really rely on it. I mean, some things may be true, but it may as well be false.
Compression, that's a good point, but compression, the way you see in our model, like we have got specific channels, and each channel, it is compressing the data, but it is sort of creating submodules of it, and so this part has these parameters, this part has these parameters, and therefore run it with the whole, what does the whole simulation mean? So compression also has the hint of a data loss, but compression is sort of filtering, but for parts of it. That's what I mean, that's where parameterization becomes important. Maybe it sort of highlights what parts are important. I don't know if that's correct, though.
Yeah, there's actually, for those who are interested, there's a talk, a very kind of boring talk, but also very exciting, by the Ilya Sutskever from the OpenAI that talks specifically about the compression and the Kolmogorov space and all kinds of interesting things. So I'll send the links in Slack for those who are interested. But yeah, very deep topic. Yeah, for the sake of the time, maybe let's give some other people space for the questions or ideas. Malavika, is anything that resonates with you here?
Yeah, I've just been, to be honest, I've not had time to go through the papers before, so I'm sort of like going through them now and parallelly following on with the discussion. This paper is quite interesting because I am directly working on LLM hallucinations and pretty much looking at how to evaluate, without references, how to evaluate the trustworthiness, similar to what they're doing in the paper. But the kind of work I look at is, so I've looked at some consistency based approaches. I think this paper, the idea is very similar to several papers that came out in 2023. Consistency based checks, this chain of verification, there's the original self check GPT paper as well, which had this idea of is it consistently choosing the correct response, although in those works they kind of generate multiple responses for the same question from the model, and then they check if each time it generates the same thing by sampling different responses. And the general idea is that the more confident the model is about a certain fact, each time you query and sample the same fact from the model, it will generate something similar. Whereas when it tends to hallucinate, each time you sample, you'll get a different set of responses. This is a little bit orthogonal in that it's also consistency based, but then instead of sampling different responses, you're basically sort of having an MCQ type thing where you make it choose each time a different response, and then check if it's actually choosing the same or different each time. Um, it's quite interesting. I'm just wondering how it aligns whether it aligns well with some other theories about LLMs being quite overconfident in their knowledge. So if you query it for something that, if you prompt it with something that was generated by the LLM itself, it would generally tend to pick it each time over anything else. So if it can be, the problem is it can be quite confident sometimes about something that's in real world not factually correct, but then for some reason the parameters contain that information and it's confident. So you will have errors where it will keep picking it consistently, but it's actually wrong. So there's, the things I am looking at are not at the prompting level, but rather the model internals themselves. And there's some evidence that um, when with even without having these distractor type responses, if you just have a single statement and if you just pass that statement through the model and analyze the activations is what we call them, which is, so the parameters are the weights which are frozen, and then based on the input sentence, the the input sentence gets converted into an embedding at the input level, and then you multiply the embedding with the weights at each layer. And then when you do that multiplication, you get some activation values which are unique to each input. So different sentences will have different activations within the model. That's what activations are. They're unique, whereas the weights is the model itself, which is permanent. So there's some evidence which I'm investigating further, that if you look at geometrically the activations, then there are, when the model is not very sure about certain factual knowledge, even though at the output level, at the prompt response level, it would look like it's quite confident, if you actually look at those activations, you will find directions in the n-dimensional space which indicate that that's actually not factually right. So that's sort of improving upon the these prompt type approaches. So that's what I was thinking about. This is interesting. I'm not very sure yet how novel this particular paper is compared to other consistency based papers I've seen before from 2023. But yeah, that felt like I went on a bit of a rant, but it's very close to my research area. So
Amazing. You went super deep, but I love it, especially in terms of inspection of, layer per layer activations.
yeah.
I mean, obviously, if we're talking about knowledge distillation and utilization of much smaller models, especially in the niche domains. So let's say, like, for example, we're right now in PolyAgent, there is a smaller group of people that is playing around with utilization of smaller models for different languages, because there's a conference and the goal is to train the model to do the Q&A multiple choice in Ukrainian. And surprisingly, there is no, large model that is good enough for that task. And during the testing, it's pretty, abundantly clear to me that some of the concepts may be in there, but there's not enough, scope of that knowledge for it to even deduce the correct answers. So it would tell you that a certain vegetable is used for, certain type of soup, and it will be consistent with that, and it will be confident, except that is not true. So I think the confidence issue and the investigation, maybe, there should be some research actually on investigating the breadth of the certain entity scope, or, set of entities or topic within the model, because that's what I'm thinking about. Like, before you establish the confidence baseline, you need to understand how much knowledge there is for that given topic for it to be confident in it. Yeah. So
Yeah,
that's my rant.
absolutely. That's actually, I think you've just sparked a very interesting research paper idea. That's quite deep, actually. It would be interesting, like if,
I'm
yeah, it might
down.
not be hard to do. You could just prompt the model in various different ways, analyze the activations to try and figure out the amount of information that's contained around the inputs.
Well, when you have some free time besides your PhD thesis, I'm down to experiment.
Yeah, it might be very interesting.
Ian?
I,
Love that idea.
I apologize if this is too far off on a tangent, but I can't help but think, in looking at a paper like this, about the limitations of its scope, in that if we're considering a single model architecture where we've got a static knowledge base, if we want to call it that. If the model is, if the training data is static, it's not evolving, then perhaps this kind of ranking system could apply. But at the moment that you apply it to an architecture where its knowledge is essentially meant to evolve over time, then you're increasing the likelihood of unexpected use cases and the probability of hallucination. So where the knowledge contained therein is dynamic, I am wondering if this is chasing a moving target. Again,
Like
specifically,
news, right?
yeah. So specifically as relates to single model architectures, as opposed to introducing a second model as a fact checker and so on and so forth.
Yeah, very interesting, especially for the use case like news and the analysis of the time series data related, events. Yeah, very good topic too. All right, we're short on time, so I'll wrap up the paper discussion. I think it was really, really great. I think the papers that, were automatically picked thanks to Wendy's notebook were a pretty good pick. I'll be upfront. Like, there were 5 papers, so there was some human element involved in, after the selection. But yeah, I think that was great. And I'll spend the next couple of minutes to give you the overview of our current progress with our own research agent as the project that we're currently trying to accomplish. the initial, the scope of work that we planned for this demo, or the session, was to have a scheduled daily ingestion of papers with a quick summary, so that every day we'll see, hey, 20 papers were ingested. Here's a quick summary of what papers are about. And the second task was to have a basic weekly digest of candidates for a paper session review. So in terms of the candidates, we have that piece of code thanks to Wendy. Now we just have to take that and transform that into the basic weekly digest. So I'm looking forward to have some progress on that in the coming weeks. In terms of daily ingestion, also thanks, Wendy, for showing us the GitHub Actions. I've never personally used that, but last night me and Anton explored that, set up a basic cron job. So that's a amazing quick thing to quickly spin up. So the only thing that it needs is the actual ingestion of the papers. But yeah, Anton, you want to add some?
So I actually already added our, essentially based on our collab with ingestion papers, I was able to run kind of like, so locally triggering the GitHub action, the same code. It seems to work. Now I'm waiting for essentially GitHub action schedule to kick the same job, not like from the GitHub servers, because there are like a lot of moving parts that could go wrong. Dependency not installed correctly, and stuff like this. The secrets passed properly into the script. So that part needs to be tested, and we should have it, sometime today when the action actually getting triggered. Hopefully no errors there, but if they are, again, we'll just deal with them later.
Yep. So good progress on both of the directions. I hope, maybe later this week we'll have this scope of work finished, and we'll have some, daily and weekly interactions going on with the agent. So to wrap this up, thank you again for everyone joining in. Super exciting to have.
Artur, sorry, about the task that I had, can I briefly talk to you maybe after this, or?
Sure. Ping me on Slack. I have the call right after, but then I'm free.
Okay, sure. Yeah, I'll do that. I mean, I can write up to the, I create the unique index and write, but about the creating the model. So maybe I just want to talk to you about it. Okay.
Sounds good.
Or
Right.
yeah. Okay, I'll bring you.
Yeah. So just to wrap it up, it was super exciting to actually have such a diverse group of people today. I think it was very interesting to hear from both research, Malavika, super deep research into the activations of the neural networks, and to hear from Raphael's perspective of commercial applications. So please join on our next session in 2 weeks. And yeah, super excited to have more of these. Unless anyone
Looking
has
forward to it.
any closing thoughts or questions. All right.
I just had a
This is
thought.
great.
Remember,
Thank you for having us.
Thank you.
All right. Thanks, everyone.
Thanks a lot.
Bye, guys.
Really appreciate that, Artur.